So this is question number 3 from 2015 of the AP Calculus exam. So the question reads, Joanna jogs along a straight path. For t is greater than or equal to 0, but less than or equal to 40, Joanna's velocity is given by a differentiable function v. Select the values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Use the data in the table to estimate the value of v prime is 16. Now there are two ways that we can get v prime is 16. Either we take the derivative of the velocity of the equation, or we find the average rate of change. Now since we do not have an equation for velocity, we'll just have to stick with finding the average rate of change. Now there is no specific value for v of 16, so we will have to use these two values, 12 and 20, since 16 is between them two. So v prime of 16 will equal v of 20 minus v of 12 all over 20 minus 12, which will equal 240 minus 200 all over 8. So this will equal to 40 over 8, which will be 5 meters per minute squared. So the reason why the units are squared is because the problem is asking for acceleration. So therefore this would be the acceleration of v prime of 16. Now the second part states that using correct units, explain the meaning of the definite integral from 0 to 40 absolute value of v of t dt. In the context of the problem, approximate the value of the absolute value of v of t dt from 0 to 40 using the right Riemann sum with the 4 subintervals indicated in the table. Now, the definite integral v of t, the absolute value of v of t dt from 0 to 40 will represent the total distance traveled. So therefore, you would say the definite integral from 0 to 40, the absolute value of v of t dt is the total distance traveled between t equals 0 to t equals 40. Now we're going to use the same integral to approximate this value. So therefore we will have to use the values from the table, but each of the subintervals will have to be equal, and we will only be using 4. So be from 0 to 40. So we will use 12 times the absolute value of v of 12 plus 8 times the absolute value of v of 20 plus 4 times the absolute value of 24. The absolute value of v of 24 plus 16 times the absolute value of v of 40. And the reason why we're putting these absolute value signs for the values of v is because we're finding the total distance while also using a Riemann sum. So this will equal 12 times 200 plus 8 times 240 plus 4 times 220 plus 16 times 150, which will equal to 2,400 plus 1,920 plus 880 plus 2,400. And so our final answer will be 7,600 meters. So this would be the approximate value of the absolute value of v at t dt from 0 to 40. Now part C says, introduces a new character, Bob. So Bob is riding his bicycle along the same path for t is greater than or equal to 0 but less than or equal to 10. Bob's velocity is modeled by b of t equals t cubed minus 6t squared plus 300, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. Now, since this is a particle motion problem, we do have the velocity, which is modeled by b of t equals t cubed minus 6t squared plus 300. So in order to find the acceleration given velocity, you would just take the derivative in order to get the acceleration. So b of t equals t cubed minus 6t squared plus 300. So the derivative of this would be 3t squared minus 12t. And so b prime of 5 will equal 3 times 5 squared minus 12 times 5. So then you will get 75 minus 60. Therefore, b of 5 would equal 15 meters per minute squared. So Bob's acceleration at time t equals 5 is 15 meters per minute squared. And also the reason why the units are squared is because this is acceleration. For part D, based on the model B from part C, find Bob's average velocity during the interval from t is greater than 0, but t is less than or equal to 10. So this problem is basically asking the average velocity. So therefore, we will use an integral. So 1 over b minus a, which would be a over b v a t dt, which will equal 1/10 times from 0 to 10. Let's see, t cubed minus 6t squared plus 300 dt. And so the antiderivative of that will be 1 over 10 times 1/4 t to the 4th minus 2t cubed plus 300 t from 0 to 10. So this will equal, so this whole thing will equal 350 meters per minute. And that is how you solve question 3 of the AP Calculus exam from 2015.